There is a moment, somewhere in the middle of a Caribbean cruise, when a passenger glances at the itinerary posted near the elevator bank and notices something has changed. A port they were expecting, St. Thomas maybe, or Grand Cayman, has been quietly replaced by somewhere else. The announcement came over the PA a few hours ago, calm and pleasant. Something about an exciting itinerary update, and a small credit applied to their onboard account. Most people shrug and go back to the buffet. What they do not realize is that they just witnessed the end of a process that began 3 days ago, involved a dedicated meteorologist, 2 escape route calculations, coordination with port authorities across 4 countries, and a decision geometry borrowed from naval doctrine. The hurricane they never saw coming was already gone from the ship's horizon, before most passengers knew it existed. That is what actually happens when a cruise ship avoids a hurricane. Not a race, not a dramatic escape, a carefully engineered disappearing act. Let's start with the question everyone assumes they already know the answer to. A modern cruise ship can move. The average cruising speed sits around 20 to 23 knots, roughly 23 to 26 miles per hour. Push the engines and the biggest ships can reach 30 knots, around 34 miles per hour. A hurricane, by comparison, crawls forward at 11 to 12 miles per hour on average. Do the math and it looks obvious. Of course, the ship can outrun the storm. It is almost twice as fast. So why is that the wrong answer? Because the storm is not a point. It is a territory. And the territory is enormous. A hurricane is not just the eye wall. It is not just the violent center spinning at 150 miles per hour. It is a system that extends outward in every direction, sometimes hundreds of miles. And the critical number, the one that maritime navigation actually uses, is not wind speed at the center. It is the edge of the 34-knot wind field. 34 knots is roughly 39 miles per hour. That sounds manageable until you understand what happens to a ship inside it. Once a vessel enters 34-knot winds, sea state deteriorates rapidly. Waves steepen. The ship's maneuverability begins to degrade. The forces acting on the hull start compounding in ways that reduce a captain's options down to almost nothing. The 34-knot boundary is not an advisory. It is a hard operational threshold, defined by NOAA, that experienced navigators treat as a wall they must never touch. Now here is the problem. That wall is not fixed. It moves. It expands. And no one knows exactly where it will be. This is where the real hidden system begins. Hurricane track forecasting is genuinely impressive. The National Hurricane Center produces models that synthesize satellite data, upper atmosphere readings, sea surface temperatures, and historical pattern data. But those models carry inherent uncertainty. The forecast error for a hurricane's track grows at a predictable rate, roughly 100 nautical miles of uncertainty per 24 hours of forecast window. At 48 hours out, the cone of probable positions is 200 nautical miles wide. At 72 hours, it is 300 nautical miles. That is a circle of uncertainty roughly the width of the Gulf of Mexico. A ship cannot avoid where a storm is. It must avoid where the storm might be. And the zone it must stay outside is not a dot on a chart. It is a probability cone the size of a small country, shifting and updating every 6 hours. This reframes everything. The ship is not solving a speed problem. Speed is almost irrelevant when the threat is this large and this uncertain. The ship is solving a geometry problem, a forecast problem, under a clock that ticks faster than most people would imagine. Decisions must be made at 48 to 72 hours before potential danger. Not when the storm appears on radar. Not when the skies cloud over. By the time a ship can see bad weather coming, the geometry of escape may already be tightening. The corridor of safe water narrows, port options disappear, fuel reserves that would allow aggressive repositioning start looking different. And yes, fuel matters here. A ship running at cruise speed is burning at a certain rate. Push toward full speed, and fuel consumption does not scale linearly, it escalates sharply. Running hard burns through reserves that were planned for the full itinerary. There are also port arrival dynamics. Arriving too early at a port generates its own costs and logistical complications. Every decision the captain makes is running 2 parallel calculations simultaneously, one for safety, one for economics, in real time, with imperfect information under conditions that are changing by the hour. Here's what that system actually looks like from the inside. Royal Caribbean keeps a named, dedicated chief meteorologist, James Van Fleet, whose job is not to read the weather app on an iPad. His role is to track storm development continuously, issue twice-daily updates during active events, coordinate with the National Hurricane Center, model impacts across the fleet's current positions, and communicate directly with ships at sea. That role exists because hurricane season runs from June 1st through November 30th, nearly half the year. And during those 6 months, the Caribbean cruise business does not slow down. It is peak season. The system must be capable of navigating this threat not occasionally, not in emergencies, but as a continuous operational baseline. The intelligence feeding that system is layered. The ship receives NHC satellite data, third-party weather routing service models, historical storm frequency charts called pilot charts that map where and when hurricanes typically develop by month and region, real-time sea surface temperature feeds, and onboard radar. Most local television meteorology operations do not have access to this range of data. The ship's bridge team is not reading a forecast. It is running a decision model. When a storm develops, the navigation process does not involve turning left and hoping for the best. The ship calculates what mariners call the CPA, the closest point of approach, to the cyclone's projected track. It plots at least 2 viable alternate corridors. It identifies hurricane haven ports, pre-designated harbors with the depth and shelter capacity to receive large vessels in deteriorating conditions. It runs those options against Port Authority communications, because a ship avoiding a storm cannot sail toward a port that is itself inside the storm's path. The whole board is moving at once. During Hurricane Irma in 2017, this system activated at full scale. Before the storm even reached the Caribbean, Royal Caribbean began altering itineraries across its fleet. The Allure of the Seas, one of the largest cruise ships in the world, carrying thousands of passengers, flipped its entire Eastern Caribbean schedule to a Western Caribbean route. The pivot was massive in operational terms. To the passengers on board, it was an announcement, a shrug, and a new port on the screen by the elevator. That seamlessness is not an accident. It is the product of something the cruise industry has quietly engineered into the structure of Caribbean itinerary design itself. If you look at how Caribbean cruise routes are structured, you start to notice something. Ships generally operate in 2 broad theaters, Eastern Caribbean and Western Caribbean. These are not just geographic descriptions. They are functionally alternate versions of the same vacation, a pre-designed swap that can be executed when one side of the basin is compromised by weather. Hurricane tracks in the Caribbean follow statistically predictable corridors. The Eastern Theater is more exposed to Atlantic storms moving westward across the Lesser Antilles. The Western Theater, Mexico, Belize, Honduras, sits in a different risk profile, shielded by geography during many storm events. This means the itinerary flip is not improvisation. It is a designed capability. The port relationships, the docking agreements, the scheduling flexibility, these were engineered for exactly this kind of lateral move. The itinerary is not just a vacation plan. It is a storm avoidance tool that happens to double as a vacation. This is where the system gets strange in a way most passengers never think to ask about. The flexibility that lets a cruise line swap St. Thomas for Cozumel in 48 hours is the same flexibility that makes Caribbean cruising economically viable during hurricane season at all. Stopping operations for 6 months is not an option. Caribbean sailings are among the highest margin itineraries in the industry. The avoidance infrastructure exists not only because safety demands it, but because stopping is too expensive. The meteorological operations system is also a revenue protection system. Both things are true simultaneously, and one was built to serve the other. If the kind of logic that runs underneath things like this, the hidden machinery that keeps industries functional beneath their polished consumer surfaces, is what you find yourself wanting more of, subscribe. This channel is built around exactly that movement, from the surface that people see to the system that actually runs underneath it. There is one more layer here, and it lives on the ship itself. Passengers who experience rough seas on a cruise are often surprised by how manageable it feels. The ship rolls less than expected. Things stay on tables. The hallways do not become obstacle courses. This is not because the sea is calm. It is because of what is attached to the hull below the waterline. Active fin stabilizers, large retractable surfaces that extend outward from both sides of the ship and automatically adjust their angle in response to wave motion. They counteract the roll in real time. The calm that passengers feel is not the absence of weather. It is an engineered illusion of absence. So even when the routing system does not have enough time or sea room to place the ship in perfectly smooth water, the ship itself is still managing the passenger experience from the inside. The system has a final layer of absorption built directly into the vessel. During Hurricane Irma, 2 ships in the Royal Caribbean Fleet, Empress of the Seas and Majesty of the Seas, did something that illustrates what this infrastructure is actually capable of when fully activated. Rather than simply repositioning to safety, they were redirected to assist communities in the Caribbean that the storm had already hit. The same avoidance architecture that exists to protect the ship from the storm became a disaster response network. It flipped modes. The vessels that had been engineered to disappear from the storm's path turned around and moved directly toward its aftermath. Step back from that for a moment and look at what the full system actually is. You have a dedicated meteorological staff monitoring storm development continuously across a 6-month operational window. You have a layered intelligence system receiving NHC data, routing models, satellite feeds, and Port Authority coordination in real time. You have itinerary structures pre-designed with lateral swap capability built in. You have a navigation process that operates on 72-hour decision horizons, calculating probability cones and plotting multiple escape corridors before the weather appears. You have a hull equipped to absorb whatever rough water the routing could not fully avoid. And you have a passenger communication system that translates all of this into a calm announcement and a credit on the account. None of this is visible. The passenger sees a new port. The passenger feels a smooth sea. The passenger receives a polite apology and an onboard credit. The industrial system underneath, the meteorology, the geometry, the economics, the port network, the stabilizers, the humanitarian response capability, is completely invisible. And that invisibility is the final design decision. The guest experience is managed specifically so that the system doing the real work stays hidden. The hospitality layer is not just a service, it is the cover story. Which brings us back to the title. How does a cruise ship outrun a hurricane? It doesn't. That framing was always a little wrong. The ship is not faster than the storm in the way that matters. It is not racing anything. It is doing something harder and stranger than racing. It is watching a probability cone 300 nautical miles wide update every 6 hours, plotting 2 escape corridors at a time, coordinating across a network of ports in 4 countries, managing its fuel arithmetic, and moving an entire floating city full of people who are entirely unaware any of this is happening, all starting 3 days before anyone on board would ever feel a drop of rain. The hurricane never arrives because the ship was never there. By the time the storm reaches the coordinates where the ship would have been, the ship is somewhere else entirely. The passengers are at a different port, and the itinerary board by the elevator already shows the updated schedule. The cruise ship is not faster than a hurricane. It is earlier, and that is the entire system. See it far enough ahead, move before it costs anything to move, and make the whole thing feel like an adventure. The passengers who never knew it happened are not a failure of communication. They are proof that it worked. I hope you enjoyed the video and learned something new about one of the most fascinating engineering marvels ever built by mankind. If you want more content like this, please subscribe and hit that like button. I'm Larry, and this is the Ship Files. Thanks for watching, and I'll see you in the next one.